The great mix-up, cement or concrete. Let's set the record straight. We're diving deep into the world of construction materials. The secret to strong foundations, unraveling the mystery of cement and concrete. Welcome Everyday Things Uncovered. Get ready to learn the key differences. Today we're exploring a fascinating topic that has puzzled many of us. What's the difference between cement and concrete? It's a question that often comes up. You might have heard someone say cement sidewalk or concrete building and wondered if they're interchangeable terms. Are these terms really one and the same? But are they really the same thing? Let's dive in and find out, separating fact from fiction. Cement is the glue, the essential binding agent that holds concrete together. It's a fine, powdery substance made by heating limestone and clay to incredibly high temperatures. A truly transformative process. But cement on its own isn't very useful. It's just a component waiting to be activated. It needs to be mixed with water, sand and gravel or crushed stone to create concrete, the final rock-solid material used in everything from sidewalks to skyscrapers. It's the mixture that makes the magic happen. When these ingredients come together, a chemical reaction occurs called hydration, which allows the mixture to harden and gain strength over time. Think of cement like flour in a cake recipe. You wouldn't eat a spoonful of flour, but when you mix it with eggs, sugar and butter, you get a cake. Similarly, cement alone doesn't do much, but when combined with other ingredients, it forms concrete, a material strong enough to build bridges, roads, and even entire buildings. The mix-up between cement and concrete is common, and it makes sense. Cement is a crucial part of concrete, so people often assume they're the same thing, but they're not. Cement is just one ingredient in the mix, like flour in a cake. Concrete is the final hardened product we see in everyday structures. The hardening of cement is a complex process that involves a series of chemical reactions. When water is added to cement, it triggers a process called hydration. During hydration, the tiny particles in the cement, known as calcium silicates, react with the water molecules to form calcium silicate hydrate gel. This gel is the primary binding agent in concrete, responsible for holding the mixture together. As the gel forms, it starts to fill in the gaps between the cement particles, creating a network of crystals that interlock and bind the mixture together. This process is known as crystallization. The crystals continue to grow and interlock over time, creating a strong and rigid structure that gives concrete its strength and durability. The hydration reaction is an ongoing process, a chemical transformation that continues for days, weeks, and even years after the initial mixing of the cement and water. This extended duration is what allows concrete to achieve its ultimate strength and durability. As the reaction progresses, the concrete continues to harden, becoming more robust and gaining strength incrementally. This gradual strengthening is crucial for its long-term performance in structures. This is why concrete is often significantly stronger after several days or weeks of curing than it is immediately after being poured. The curing period allows the hydration process to fully develop the concrete's internal structure. However, the final strength of concrete isn't just a matter of time. There are several key factors that can significantly influence the rate and extent of the hydration reaction, ultimately affecting the concrete's overall quality and performance. These factors include water to cement ratio. The precise amount of water added to the cement plays a critical role and can directly affect the rate of hydration. Too much water can slow down the reaction, leading to weaker concrete, while too little water can make it difficult to mix and properly place the concrete, hindering the hydration process. Temperature. The ambient temperature of the environment surrounding the concrete can also significantly impact the hydration reaction. Higher temperatures can accelerate the reaction, potentially leading to rapid setting, while lower temperatures can slow it down considerably, extending the curing time. Cement composition. The specific type and chemical composition of the cement used in the mixture can also significantly affect the hydration reaction. Different types of cement, such as ordinary Portland cement or various blended cement options, each possess different hydration rates and unique characteristics that influence the final concrete properties. Admixtures. Furthermore, admixtures, which are specialized chemicals, are often added to the concrete mixture to enhance or modify its properties. Some admixtures can act as accelerators, speeding up the hydration reaction, while others function as retarders, slowing it down, depending on their specific chemical composition and the dosage used in the mix. Overall, the hardening of cement is a complex process that involves a series of chemical reactions. Understanding these reactions and the factors that influence them can help engineers and builders create stronger, more durable concrete structures. The ancient Romans were masters of cement-based construction. They developed a form of concrete using volcanic ash, which helped structures like the Pantheon and aqueducts stand the test of time. Some of their concrete structures are still standing over 2,000 years later. Not all cement is the same though. There are various types, each designed for specific conditions. For example, sulfate-resistant cement is used in environments where concrete is exposed to harsh chemicals like seawater. Rapid hardening cement sets faster than regular cement, making it useful for projects that need to be completed quickly. Concrete too comes in many forms, each designed for a specific purpose. From sidewalks to skyscrapers, the versatility of concrete is truly remarkable. Some types are reinforced with steel bars, known as rebar, to make them even stronger and more resistant to tension. Other formulations are mixed with air bubbles to create lightweight, insulating concrete, ideal for temperature control and energy efficiency. And in an amazing feat of engineering, there's even self-healing concrete. This innovative material contains bacteria that produce limestone, effectively filling in cracks over time and extending the lifespan of structures. Getting the right balance of ingredients is absolutely crucial for making strong, durable concrete. The precise proportions determine the final strength and integrity of the material. Too much water can weaken the final product, leading to a less robust structure, while too little can make it incredibly hard to work with, hindering proper placement and finishing. That's why construction workers meticulously follow precise ratios and established guidelines when mixing concrete, ensuring consistent quality and performance. In conclusion, understanding the difference between cement and concrete isn't just about technical accuracy or impressing your friends with construction trivia. It helps us appreciate the materials that literally shape our world, influencing everything from our daily commutes to the buildings we inhabit. Whether it's the foundation of your house providing stability, the roads you drive on facilitating transportation, or the towering skyscrapers that define city skylines, concrete is a fundamental and indispensable part of modern life. And now, armed with this knowledge, you can confidently explain the crucial difference between cement and concrete to anyone who gets them mixed up, spreading clarity and understanding about this essential material. Your input truly matters to us. Share your innovative ideas and suggestions for our next video in the comments section below, and we'll gladly recognize your valuable contribution. Thanks for joining us today on this exciting exploration of the fascinating and often surprising stories behind the everyday things we often take for granted. Don't forget to give us a like, subscribe to our channel, and hit that notification bell to stay tuned for even more captivating content in the future. Thanks so much for watching. And if you're eager and want to learn even more, simply click the next video suggestion right here on the screen.